Great. So my name's Mark Leith. I'm a senior software development manager in Oracle. I actually work in what's called the Enterprise Tools team in Oracle. So my responsibility is actually a tool called MySQL Enterprise Monitor, which comes with the subscription in MySQL. I'm also the original developer of the sys schema, which is now included in 5.7 by default. And because I have so much responsibility around the monitoring tool, I also have a whole bunch of input into all of the instrumentation in the server as well. So I've had a lot of input into shaping performance schema and a lot of the other instrumentation in the server as well. So a quick overview of what I'll talk today. First, why you should instrument your plugins in Performance Schema. I think Valerie did a pretty good job of describing why a minute ago. A quick look at the interfaces that are available to actually use from Performance Schema itself. Show a few examples of how you'd take your current code in a plugin and push it into the instrumented interfaces. And then answer any questions. Before I would do that, I want to get an idea of, has anybody actually written a plugin with a plugin for MySQL? Wow, that's more people than I expected. Some of you are actually developers on Oracle, though. That's wrong. Have any of you actually considered writing plugins for MySQL? Yeah, a couple. So the why. People don't really realize that as MySQL has moved on over the years, we've actually added a whole bunch of really good interfaces into the server. So you hear a lot that there's not enough instrumentation, I want to do firewalling and all of this kind of stuff. Over the years, we've added a bunch of interfaces, not just storage engines, but being able to do things like pre and post parse plugins, so you can get into the stream of SQL and see what it's doing, change it along the way, block it with firewalling, those kind of things. We have an audit interface. We have our own audit plugin that we have with Oracle. There are other ones that are out there, like the one that Bacona has and Maria. But the other thing is, with that data, you can do your own thing, right? There's a lot of data that you can get in the audit stream about who is doing what kind of problems are coming up with errors, those kind of things. So it's a great interface. That's probably the one that I think most people should look at, or most DBAs that want to trace what's going on in their systems. And I'll give an example based on the audit one today. We also have full text search. Not many people use that. Information schema tables can be pluggable as well. So you can, again, look at or get a whole bunch of data from the server and expose that if you want to. I've written, for instance, information schema tables in the past that go off and do system calls and find CPU usage and IO usage and all of that kind of stuff. It's not hard to write those kind of things. And then replication interfaces, as we've worked on things like group replication and the like, we have given interfaces into the binary log streams as well. So those are things that people can, I think, will start to pick up and use more, as we do integration with other big data systems. You can interact with the binary log stream and, for instance, throw it over to Kafka or whatever you want to do on that side. So there's a lot of great interfaces there. But as they're doing a whole bunch of work, you need to instrument them as well. And if you don't do that, you saw the example from Valerie earlier, where, for example, RocksDB was waiting for a whole bunch of time, waiting for a mutex, right? He had to go off and use perf for that. Performance Schema does track mutexes, and it could have shown that as well. So it is essentially creating your own new black holes, right? I mean, this is the way that I look at the server. The little points of light are essentially instruments in Performance Schema. The black hole is essentially, you don't know what is happening in the server. That used to be a supermassive black hole before Performance Schema came along, essentially. But yeah, you should try and shrink those as much as possible. So the interfaces themselves, the main interface is all in this include MySQL PSI directory. It has the psi.h file, which is essentially the ABI. Within that one, it's a versioned interface, but exposed as a standard interface. So you use the standard interface, and it calls out to the versioned interfaces appropriately. And the first thing I'd say is go off and read this document. We've put a bunch of work into actually doing proper documentation in Doxygen format. The performance schema interface is a great example of that as well. It's probably the better documented interface in Doxygen right now. So go and have a read of that file. I mean, or that section of the manual, essentially. It tells you all about the ethos of how performance schema should work and is instrumented, and how it's architected in the background, and then gives you a whole bunch of info in how to use these interfaces. So that's where I'd start, essentially. The API itself is broken down into these smaller header files. So these are pretty much the main ones that you'll use as a performance or a plugin developer. So the first one is this MySQL thread header file. That was almost the original one that came along with 5.5. So in 5.5, we instrumented mutexes, read-write locks, conditions, file I/O as well, and threads themselves. So if you're doing anything like creating a thread or locking a mutex, creating a mutex, anything with the standard POSIX interface on those things, in the thread header, what we essentially do is we wrap all of those interfaces, the standard POSIX interfaces, with our own instrumentation. So we call into performance schema, say that we're going to start some wait, whatever it may be. We do the standard POSIX call, and then we call in afterwards and say, hey, I've finished, essentially. That's all that these do. So they create a bunch of macros. If performance schema is not enabled, they basically turn into no ops. And if it is enabled, it turns into, we'll do some instrumentation of this section of the code. So if you create a thread, or, well, a lot of plugins don't create threads, but if you do that, then you'll do it through there. With file I/O, it's all in this MySQL file header. Again, same simple thing. So if you're doing an open of a file or a write of a file or whatever it is, you'd instead go and look in this interface. The nice thing about the file interface is actually it will end up shrinking your code a little bit as well, and I'll talk about that in a minute as well. Memory is new in 5.7, so if you're allocating memory, then use this interface. So instead of a malloc, you do a MySQL malloc, all of those kind of things. And what we'll do there is not so much track the time spent, but track the overall memory that you're allocating over time in your plugins as well. Network I/O is standard stuff, so both socket and TCP. Not a lot of plugins tend to do that, but you can do that in plugins as well. Each of these, they all call out to the underlying PSI and use the PSI interfaces through the versioned API. So let's dream a little bit. We'll imagine you're going to create an audit log plugin. It's going to log some stuff to a file, track some stats. What you basically need to be able to do with that is open the file, write to it in some way, maybe sync it from time to time. You'll also have to have a mutex to protect the file access, because you'll have multiple threads trying to do this stuff at one point in time. So it's a fairly simple plugin, but just imagine that kind of plugin and what you'd need to do for it. So when you come in to start doing this stuff, originally you'll start off with, if you haven't, or if you've written a plugin, not many of you have, if you had written one, you'd have something like a pthread mutex T. You'll go into an init, you'll init the mutex in some way. What you do with Performance Schema to actually push this stuff into Performance Schema is you instead use this MySQL mutex. So essentially, most of the POSIX interface, you can replace the pthread with a MySQL, and you'll be done from that perspective. So you pretty much like for like change that. The next line you'll see there, and I hope you guys can read that bit over there. But the next line you see there is actually giving it a key. So when you look at Performance Schema, each of the instrument names, they all start with something, they have a category, and they have their end name. That's essentially the key that you create here. You create an array of those things as well. You can actually do you can init them once without the array, but the interface allows both an array or a single one to be passed. So if you have multiple mutexes, you'd add them all to this array. You give the category, right? You see where I'm saying this category client error. That's generally you'd name that your plugin name. Better. Yeah, generally that would be your plugin name. So we'll call it client error. And then we count how many values are in that array. Again, you don't have to do this. You can go straight to the register. But if you use an array, count the number of things in the array, pass it to this registration function. And the thing that I should have done here, actually, I missed it out, is you include the MySQL thread header file as well, of course. And then you go and register the mutexes themselves. That's actually calling into Performance Schema and saying, hey, I've got these mutexes, you need to track them in some way. You need to expose them in the instruments table to let people turn them on or off, those kind of things. So once you've registered, you then go off and actually init your mutex like you would with pthread, but instead using MySQL. So it's a fairly simple change, right? For the most part, you're changing the prefix of whatever you're doing and creating some key to register it within Performance Schema and then registering it, essentially. So similar with files, but before you'd have some file pointer, you'd go off and do an fopen standard interface, basically. Error, at the end of it in the audit class, we log, and we're going into the end of the actual query run. But if you're doing other kinds of plugins, you may consider where you sit in that and how to actually instrument the rest of the instrumentation after that, basically. And that's pretty much it from me. Any questions? So the question is, what if there's a lot of files? If you have a lot of files that are created by your plugin, should you instrument them singly or all as one? You should instrument them all singly, right? I mean, the point with a lot of this stuff is to drill down at that little point of light, right? And find out, in the file I/O case, who's creating the most I/O. If you do it all as one file, you can't do that, right? You need to track it down to one file. The one thing that you have to consider is we have these max counters in Performance Schema, right? Max mutexes and max files and those kind of things. We set those based on our defaults of what we need generally. So one of the things that you might consider after you've done that is increasing those max things as the defaults in the server itself. You can see that they get lost, right? You have these Performance Schema XX lost counters that are in the status counters. If you have the file one actually losing instrumentation, then you have to increase it. So I mean, you consider the increased buffers and everything that comes with it, but never mush everything into one. I wouldn't anyway, right? Because it hides where time is being spent again.
An example where everything is missing is writing the bin logs, right?
No, because bin logs are actually tracked individually as well, right? If you look in the file instances table in Performance Schema, every single bin log is there. So we don't mush it all into one. It's a bin log event type, but the instances of those are each individual bin log. Okay, thanks.
You did great.